Hey guys, this is Vamakshi Verma and you are watching The Central Science. In India, the summer is about to end. And with this, I am also ending with this chapter, Heat, with two interesting topics related to it. So let's start. So the first topic is humidity. So let's consider few things to understand this topic. So our earth is composed of 71% of water. And when this water evaporates, it converts into water vapor. And this water vapor goes in the atmosphere. So this water vapor makes the air moist. And this moisture is nothing but humidity. So you can see this line here. It says that this water vapor that has evaporated makes the air moist, and this moisture in the atmosphere is called as the humidity. But for a given volume of air, as you can see a beautiful picture of our atmosphere, so for a given volume of air present at that atmosphere at a certain temperature, there is a limit. Okay, so there exists a limit. Limit on what? Limit on the water vapor content that can exist in that particular area of that atmosphere. So basically, humidity is measured in kilogram per meter cube, where water vapor content is measured in kilogram and volume of the air is measured in meter cube. That is, humidity is measured in terms of mass of water vapor, and volume of air is measured by the volume of the air that is contained in that particular atmosphere in that particular area. So let's see some points related to humidity. So here is the first point. When the water vapor content is less than as compared to the air, then the air is known as unsaturated air. It means when the limit of water vapor content is less than that compared to the total air present in that particular area, the air is said to be unsaturated with respect to the water vapor content. Similarly, when the water vapor content is equal to that of the air, then the air is known as saturated. This means that if the limit of water vapor content is equal to that compared to the air, then the air is saturated with respect to the water vapor content. Now, the next point says that if unsaturated air, that is this air where the water vapor content was less as compared to the air, so when the unsaturated air is taken at a certain temperature and the temperature there is decreased, then the air becomes saturated with the vapor, and this temperature is known as the dew point of the dew point temperature. Okay, now this point explains that if suppose that I have a particular area where some air is present at the temperature of say 50 degrees Celsius, and if I take that air for experimentation and I reduce the temperature to 20 degrees Celsius because of the cooling of the air contained in that experimental setup, because of the temperature is decreased now, the vapor present in the air would now become equal to the amount of air present in that setup. So this will lead to a dew point temperature where the water vapor content is now actually increased as compared to the air content, and here the dew point will start forming. Now, this humidity is mathematically calculated by this formula where it says that percent relative humidity is equal to the actual mass of water vapor content in the air in a given volume divided by mass of vapor needed to make the air saturated in that volume multiplied by 100. So this multiplied by 100 is nothing but the calculation of percentage. Okay. Now, what is the actual mass of water vapor content? The actual mass of water vapor present in the air is the amount of water vapor which is present in the air at a certain temperature at that particular instant. Okay. Now, what is this mass of vapor needed to make the air saturated in that volume? So it is nothing but the mass of vapor that is needed, that is actually needed to make the air saturated, so that the mass of vapor content and the air present in that volume, in that atmosphere becomes almost equal. So basically, saturation here means that no more space is available in the air to accommodate any more water vapor particles. Okay, so if the relative humidity is calculated by this formula and it gives the answer as 100%, that is the actual mass of water vapor content in the air and the mass of water vapor needed to make the air saturated, both are same. So the answer comes up to be 100%. And if the answer comes up to be 100%, it leads to the formation of dew point, which is like this and which you have already observed in your environment. If the relative humidity answer is less than 60%, so you will feel that the air is dry, which you normally feel in the winter season where your skin appears to be dry. If the relative humidity is more than 60%, so you feel that the air is humid and you normally sweat, which is seen in summer, as you must be feeling it right now. Let's see an interesting example related to this. You must have seen a white trail in the sky formed due to the aeroplane, isn't it? This is because in this particular volume of air, the water vapor has made the air saturated already, because of which the water vapors released by the plane is not accommodated in that particular atmosphere and the white trail appears. But as soon as there is some space formed in the air, it quickly accommodates the water vapor and the white trail disappears. Interesting, isn't it? So this is all about the humidity and the dew point, and I hope that you have understood it very well. Now let's see the last topic, which is the anomalous behavior of water. So for this, let's consider few examples related to this topic. So here is the first picture, which depicts that the metal is expanding when it is being heated. And you can see that the second metal, that is the steel, is expanding more as compared to this alumina. This is because it has different specific heat capacity, which I have explained in the previous videos. You can watch it. You can see this example also, where because of heat, the funnel of this machine is expanding. There are many such examples which basically explains that any kind of object, whether it be solid, liquid or gas, when heated, they expand and when cooled, they contract. So this is the basic fundamental thing that substances when heated, they expand and when they are cooled, they contract. But there is a very special behavior which is seen in case of water, where water expands on cooling and it contracts on heating. Again, this is also interesting, isn't it? Let's see how. So basically, this whole phenomena occurs in between 0 to 4 degrees Celsius. For this, here is a graph which explains everything, and you can see here that volume is plotted on y-axis and the temperature is plotted on x-axis. So as the temperature increases, as you can see here, as the temperature increases, that is from 0 to 4 degrees Celsius, you can see that the volume is decreasing, which is clearly saying that on heating the water and raising its temperature from 0 degree to 4 degree, it undergoes contraction, because of which volume is decreasing. And here we can see that the same phenomena when occur in the opposite direction, that is, if we cool it from 4 degree and bring it to 0 degree, then the volume increases, that is, it is being expanded. To understand this phenomena more nicely, we have Hope's apparatus, which is this, which we are going to study with respect to this graph. Let's see this apparatus in detail. So, we have a cylinder here which contains cold water. The cylinder is surrounded by a freezing mixture jacket. There are two thermometers attached to this cylinder. One is above the jacket and one is below the jacket. This thermometer measures the temperature, which is denoted by T2, and the below one measures the temperature, which is denoted by T1. The freezing mixture can be ice and some salt. This outlet is used to remove the melted ice from this apparatus so that it does not causes any kind of hindrance. Let's see the procedure followed in this apparatus. This jacket contains ice, and due to this coldness of ice, the water that is indirectly in contact with this jacket gets colder first. That is, the temperature is decreasing, as you can see in this graph. Okay, so the temperature of the water, suppose the temperature of the water in the cylinder was 9 degrees Celsius. So because of the contact of this ice, the temperature is now decreasing, and because of this temperature decreasing, the volume is also decreasing. Okay, now if the volume is decreasing, the density of this water will start increasing. How? This is the formula of density, which is equal to mass upon volume, where we can clearly see that density is inversely proportional to the volume. So as the volume decreases, the density increases. And when an object has greater density, it becomes heavy. So this water will automatically come down. Okay, that is, the water will come here, and the water becomes heavy. That is, the process of this coldness, that the water will become heavy, continues till it comes to 4 degrees Celsius. Because in case of water at 4 degrees Celsius, the volume is the least, as you can see here, and because the volume is least, the density is the highest. Now, as the water gets more colder, the temperature decreases further, that is, below 4 degrees Celsius. And as the temperature decreases, it traces this path from 4 degree to 0 degree. And as you can see in this graph, the volume starts increasing. And if the volume starts increasing, again, by this formula, we can see that if the volume increases, the density will decrease. And if the density decreases, this water will come upwards, because now the water has become light in weight because of the less density. So all the water which was down here will move upwards due to its light weight. So the thermometers which were attached here to measure the temperature says that the above water which was above the freezing mixture becomes 0 degree first, and at that point of instant the below water, that is below the freezing mixture, remains at 4 degrees Celsius only. Obviously, after some time, the whole water in this cylinder will become 0 degrees Celsius. But for that particular instant, the water here is at 0 degrees Celsius, and it achieves that temperature first as compared to the below water. You can see here in this graph also at 4 degrees Celsius the volume of the water is the least, and because it is least the density is the highest, and therefore the water becomes more heavy at 4 degrees Celsius. But when it is becoming more colder, the volume increases, because of which the density decreases, because of which the weight of the water becomes lighter. Okay. This anomalous behavior of water becomes the reason why fishes can stay alive in the water in the cold regions too. Because of this phenomena, the upper layer of the water in the cold regions transforms into ice first, and the lower layers remain as the chilled water where the fishes can swim freely. So this was all about the anomalous behavior of water as well as the chapter heat. I hope you guys like it. If yes, press the like button and share it with your friends. And please don't forget to subscribe to the channel that you are watching, the Central Science. Thank you all.